universe has once again proven its unpredictability with the discovery of an enigmatic cosmic signal that defies our current understanding of astrophysics. This extraordinary signal, which repeats with remarkable precision every 53.8 minutes, has left scientists worldwide both baffled and excited about what it could mean for our understanding of the cosmos. Deep in the vast expanse of space, a bizarre radio signal is challenging everything we thought we knew about stellar physics. Unlike anything astronomers have observed before, this signal cycles through 3 distinct states with clockwork regularity, completing a full cycle every 53.8 minutes, a behavior that doesn't align with any known astrophysical object. What makes this signal truly extraordinary is not just its periodic nature, but its 3-phase behavior, explains Dr. Elena Ramirez, senior astrophysicist at the South African Radio Astronomy Observatory. We observe bright, highly polarized flashes that suddenly transition to faint circular bursts, followed by complete silence. Then, like clockwork, the cycle begins again. The signal's peculiar characteristics have astronomers questioning fundamental models of stellar evolution. Neutron stars typically rotate in seconds or milliseconds, not nearly an hour. White dwarfs, while slower rotating, aren't known to emit radio signals with such distinctive properties. This cosmic anomaly stands as a testament to how much we still have to learn about our universe. The discovery journey. The detection of this perplexing signal came through South Africa's MeerKAT radio telescope, one of the most sensitive radio observatories in the world. What began as routine data collection quickly transformed into one of astronomy's most intriguing puzzles, when scientists noticed a pattern that shouldn't exist according to current astrophysical models. Without MeerKAT's incredible sensitivity, we might never have believed these signals were coming from a single cosmic source, notes Dr. James Chen of the International Astronomical Consortium. The telescope's ability to detect subtle variations in radio emissions was crucial in confirming all 3 signal states originated from the same location. Understanding cosmic radio emissions. To appreciate why this discovery is so revolutionary, we need to explore how celestial objects typically emit radio waves. Most radio signals from space come from predictable sources with well-understood mechanisms. Traditional radio sources, pulsars, rapidly spinning neutron stars, are among the most common sources of periodic radio signals. These stellar remnants rotate at incredible speeds, sometimes hundreds of times per second, sending beams of radiation that sweep across Earth like cosmic lighthouses. When we detect these beams, they appear as regular pulses, with periods typically ranging from milliseconds to seconds. Fast radio bursts, FRBs, represent another category of space signals. Powerful millisecond-long radio flashes that can release as much energy in a fraction of a second as the Sun produces in decades. While most FRBs are one-time events, astronomers have discovered some that repeat, though usually without the strict periodicity of pulsars. The first repeating FRB was only identified in 2015, explains Dr. Victoria Caspi from McGill University. Since then, we've found several more, proving these aren't anomalous phenomena, but real astrophysical events that require explanation. The spectrum of mysterious signals. The 53.8-minute signal joins a growing catalogue of perplexing cosmic transmissions that defy easy categorization. In 2020, astronomers detected a signal repeating every 16 days from a source 500 million light-years away. In 2022, an unusual set of radio pulses repeating every 18 minutes was observed. Recently, in March 2025, researchers solved the mystery of a 2-hour repeating signal, tracing it to a binary system containing a white dwarf and red dwarf in close orbit. NASA has documented a signal repeating every 22 minutes that has apparently been beaming toward Earth for 35 years. What makes the 53.8-minute signal stand apart is its unique 3-phase cycle and the fact that it doesn't fit neatly into any known class of astronomical objects. Scientific implications. Why this matters. The discovery challenges fundamental assumptions about stellar evolution and radio wave emission mechanisms. If this signal originates from neither a typical neutron star nor a standard white dwarf, astronomers may need to revise core models that have guided astrophysics for decades. we're potentially witnessing an entirely new class of stellar objects. This signal could represent the missing link between different evolutionary stages of stars, or perhaps something we haven't even conceptualized yet. Pushing the boundaries of known physics, the interplay between extreme magnetic fields and plasma flows might explain some aspects of the signal's behavior, but current models fail to predict the erratic nature observed in the data. This suggests we may be missing fundamental pieces of cosmic physics. Sometimes, the most valuable discoveries in science are those that don't fit our existing frameworks. These unexplained phenomena force us to question our assumptions and potentially discover new physical principles. Potential explanations. Scientists have proposed several theories to explain this mysterious 53.8-minute repeating signal, though none fully account for all observed characteristics. One possibility involves an unusually slow-rotating neutron star with an exceptionally strong magnetic field. While typical neutron stars rotate much faster, theoretical models suggest that under certain conditions, magnetic braking could dramatically slow a neutron star's rotation. Is that we can't explain how such a slow-rotating neutron star maintains enough energy to produce the powerful radio bursts we're observing. It's like finding a toy top that spins for hours without slowing down. It defies the physics we understand. The white dwarf alternative. White dwarfs, dense stellar remnants about the size of Earth, typically rotate much more slowly than neutron stars, making their rotation periods more compatible with the observed 53.8-minute cycle. However, standard white dwarfs don't generate the strong magnetic fields necessary to produce such distinctive radio emissions. We're considering the possibility of a highly magnetized white dwarf with unusual properties, suggests stellar evolution specialist Dr. Joanna Miller. Perhaps one that formed through the merger of two white dwarfs, creating a magnetic field configuration unlike anything we've observed before. Binary system dynamics. Recent discoveries point to binary star systems as potential sources of repeating radio signals. The 2-hour repeating signal solved in March 2025 originates from a binary system where the magnetic fields of a white dwarf and red dwarf repeatedly collide as they orbit each other. While a binary system could potentially explain the periodicity, the three distinct states of the 53.8-minute signal make this explanation challenging. We'd need a complex interaction between the two stars that systematically produces these three different emission states. Something entirely new? Perhaps most intriguingly, this signal might represent an entirely new class of cosmic objects or phenomena. History teaches us that unexplained astronomical observations often lead to revolutionary discoveries, from pulsars themselves to the more recent fast radio bursts. Technology behind the discovery. The MeerKAT radio telescope array in South Africa played a crucial role in confirming this discovery. Comprising 64 dishes, each 13.5 meters in diameter, MeerKAT represents a technological marvel that allows astronomers to detect incredibly faint radio signals from the distant universe. MeerKAT's design gives it exceptional sensitivity and resolution. Without this technology, the subtle transitions between the signal's three states might have been missed or misinterpreted as coming from different sources. The discovery highlights how advances in radio astronomy technology continue to reveal new cosmic mysteries. Similar discoveries have come from other cutting-edge facilities, like Canada's CHIME telescope, which has detected numerous repeating fast radio bursts. The broader context of space signals. The 53.8-minute signal joins a growing list of space mysteries that have captured scientists' attention. In December 2024, astronomers traced slow, repeating bursts of radio waves to a binary system containing a red dwarf star paired with a white dwarf. This discovery provided valuable insights into how interacting stellar magnetic fields can produce periodic radio emissions. Other significant findings include NASA's detection of a signal repeating every 22 minutes, which has apparently been transmitted toward Earth for 35 years since 1988. Located approximately 15,000 light-years away, this signal represents another piece in the puzzle of understanding unusual cosmic radio sources. Each of these discoveries teaches us something new about the universe. Together, they're helping us build a more complete picture of the diverse ways that stars and other cosmic objects can interact with their surroundings to produce radio emissions. What comes next? The discovery of the 53.8-minute signal opens numerous avenues for future research. Astronomers are now concentrating efforts on 1. Pinpointing the exact location of the signal source through multi-telescope observations. 2. Analyzing the signal across different wavelengths to understand its energy profile. 3. Developing new theoretical models that could explain the three-state cycle. 4. Searching for similar signals elsewhere in the galaxy. This is just the beginning of a fascinating scientific journey. We've assembled an international team to continuously monitor this signal and determine whether its properties change over time, which could provide crucial clues about its nature. The 53.8-minute repeating signal reminds us that the universe still holds countless mysteries waiting to be discovered. What makes astronomy so compelling is precisely these moments, when observations challenge established theories and push us to expand our understanding. Whether this signal ultimately proves to be an exotic variant of a known astronomical object or something entirely new, its discovery has already accomplished something important. It has forced scientists to question fundamental assumptions about stellar evolution and cosmic radio emissions. As we continue to develop more powerful telescopes and more sophisticated analysis techniques, we can expect more such surprises. Each unexplained signal, each anomalous observation, represents not just a puzzle to be solved, but an opportunity to deepen our understanding of the cosmos. The quest to understand this 53.8-minute signal continues, reminding us that in astronomy, as in all sciences, the most exciting phrase isn't "Eureka, I've found it," but rather, "That's strange. I wonder what's causing that." Drop down your views as well in the comment box, and subscribe for more.